Alright, so we're starting on page 7. Super Review Calculus 1.2 Inequalities. To solve linear inequality, ax plus b is greater than 0, or x is greater than negative b forward slash a over a, where a is greater than 0. Draw a number line dashed for x, so you can see right here, x is less than negative b over a on the dotted line, and solid for x is greater than negative b forward slash a. So right there would be greater than, and over here would be less than. To solve, ax plus b times cx plus d is greater than 0 graphically, where a is greater than 0 and c is greater than 0. And you can actually see how it's illustrated in here. It kind of shows it. Alright. The solution lies in the interval where both lines are dashed and both lines are solid. Hence, x is greater than negative d forward slash c. X is less than negative b over a is a solution in the above inequality. So that'd be right here. You can see it. Alright, so now moving on to page 8, we're going to go to the problem solving examples. Solve the inequality. So that's the inequality we're going to solve. And then for the inequality, it can be represented as negative 1 that's less than 3 minus 2x is less than 1. By subtracting 3 from all the terms, we have negative 4 is less than negative 2x is less than negative 2. By multiplying all terms by negative 1/2 and remembering to reverse the signs of inequalities, we have 2 is greater than x is greater than 1, or all values in the open interval. So now right here, it says graph the following inequality. First inequality consists of an infinite strip between the lines x equal 2 and x equal 3. Note that the points in the line are x equal 2 are included, but the points on the x equal 3 are not. For the second inequality, 2 cases must be considered depending on whether y2 is positive or negative. This can be expressed as negative 1/2 because it's a negative 2, which means you're going to put over 1 because it's negative, is less than y minus 2 is less than 1/2. Adding 2 of these to each term to simplify gives 3 over 2 is less than y is less than 5 over 2. This is an infinite strip which intersects the first one in the rectangle with vertices at the point 2, 3 over 2 and 3 and 3 over 2. And 2 and 5 over 2. The result is actually a square. Therefore, all points inside this square satisfy both inequalities. However, in addition, the points in the boundary square along the line of x equal 2 left boundary, except for the corners, also satisfy both inequalities. And that'll conclude for lesson 1.2.